Hello guys, and welcome to another programming video. I don't do these very often. You might have seen some computer craft videos I made long ago. But if you've been on my Discord this year, you might have seen a bit of programming stuff, especially the progress on making this thing. Well, what is it? It's a game-like scrolling world. Well, it could be a game, but it has no game content yet. I can only move around in the game or in between maps. I have a tool to draw maps, and I have let's see, a map system, you can say, with the maps in separate files and an XML file to keep them all together. And I read all of this when I start the game-like map thingy, and then we can move around in them. So I'll go through the code, not every road, of course, but enough to give you an idea of how I did this. Not saying this is the best way to do it, far from it, but I mean, it might be interesting. But I can't do much more than this. Move around, I can move diagonally, I can move not through solid objects, but I can move between maps. So that's about it. So let's start with going through what a map is. So as you can see, I'm moving on top of something in the background, but there's also trees. These trees are in the second layer, same as these cliffs and these signs and all that. So I can place a sign on a road if I want to. And then on top of that, I'm drawing the character. But the thing with the two-layer system is that every map consists of two layers. So let's go, I can show you the idea of a map in this hex editor. So here we can see map 1.1, that's this one. So, and I know how big it is. It's in Y, it's 1E. That means, let's see, hex. That means 30 high and 28 wide. That's the width, so it's 40 wide. So 40 times 30, perhaps should have them in a different order, but it doesn't really matter. And then the rest of the map, starting from this, 83, that's the top left, that's the one here. So all of these are called 0x83. And then, so you can see it here, and then the front layer, so this is the back layer, and then the front layer in that tile is 0, and 0 is transparent. I'll give you a more detail of different tiles later, but the idea here is to have these two as a pair. They form the top left, and then this is the next pair is the next tile, and we go from top left to bottom right, and these are the values that gives me the information, so I know how to draw it and read it. So I have a few files for that. These 7 files, I think you've seen most of them already. And I read them upon when I start the, let's call it a game, it's easier that way. So when I start the game, I read them all. Here's a small map, for example. It has no scrolling at all. I can only move around within the map. So if we take a look at the second map in hex mode, we can see that they are 0f high. So that's 15 tiles high, and then 14 wide, that's 20. So 20 by 15, that's the smallest map, and they're not allowed to be in a smaller than that, and that would probably crash the game quite a bit. And then it works like this. When I'm in a map like this, I'm only drawing what you can see, and so if I scroll sideways, there's always one half tile here and half a tile here. So I read one tile extra in total, and then I just offset it where to draw it. Even though the map out here, so what comes now, it's loaded in memory, but I'm not drawing it. I'm only drawing what we can see. Okay, so I think with that, we should actually get going with some code. I have an XML file, as I mentioned, for map data. It only handles where the different teleports are, and a teleport is basically where we jump from one place to another. This is a teleport. We will jump from probably the top one. Yeah, this is the one. So a teleport from coordinate 20, 0 into map 2 in coordinate 11, 14. That's this one. Now let's take a look at what we start with, and that's I have a support class creating a DLL file, and I used this in all the other files. You can see here that we have this one is the game itself, or yeah, let's call it a game. That's the scrolling word game, and then I have the graphics. That's a DLL file that I created in this project. Then we have a location tool, and I have the map making tool. But everything starts here with a tile. And what is a tile? It has a name, it has a value, that's the hex number, the value. These ones, 83 or 0 or whatever. It has a value to see if it's solid or not, if we can go through it, or if it's a wall or something, anything like that. And then of course the image, so we can use it all over again. And the name is of course not used here. I'm not looking at the name of the tile, but when we draw, it makes sense to have a name for it. So let's quickly go through. I have two methods here in this support class. We have load graphics from the background, and then exactly the same thing for the foreground. So I'm creating a list. These constants are just only to make the creation of my tiles easier to follow further down, but is solid is true and not solid is false. And this method, we will send back a list of tiles, a list with the tiles that we have up here. So here I take a file where we have our graphics and, for example, grass. It's in here. And it looks like this. Nothing special about that, but we need to read it. So here I read the different, here I have the names, I have the value that I give them. So if you take a look in let's see, in here, and we'll have the first value as 0 somewhere, here for example, that means that it's a grass 0 tile. It's not solid, and we clone the map with a rectangle of the tile size in a space. So I clone this part or this part or this part, and I only use the ones I'm interested in. In this file I'm using, or in this picture, I'm using all the graphics. So I read them, grass to 0 to 2, path 0 to 2, and then I'm done with that file. So I'll continue with the next one. And I have lots of graphics here. I will show them just in a few minutes in the map making tool. But the interesting part here is to, for example, here shore. Here we have the water, so we have sand in the beginning. It's not solid. We have then the rest of the water is solid, and here we actually found the 0x83 that we had in the top left corner, and that's the dark blue. That's 83. So I do this, check all the graphics. There are some that are important, making sure that, for example, 0xFF in the background shall be empty, and I'm keeping the FE as black. So I always know that I can fall back on that as a default value or whatever. So I want to have these knowns, but the rest of them doesn't really matter. But when you started to draw the maps, you kind of want to keep to them. Otherwise, you need to change and redraw all your maps. In the end, I just return the graphics, the list of tiles, and return it. And I'm doing exactly the same thing with the foreground. I just separated them so I can have them in different methods, but they work identically. Here I have a fixed value for the 0x00, and that's the foreground for transparent. I want it to be empty. That's just a transparent PNG. So I can have that as a default value when we draw a map, so we always start with a transparent foreground. Okay, and that's about it. I have only one more method in here that I use from the other tools. It's a resize bitmap, where I send a bitmap and a scale value, and I just return the resized. So, and we'll see it very, very soon. These are 16 by 16, but I draw them in scale, I can't remember, 2 or 3. 3, I think. So I just simple rescale. I had to mess around with it quite a bit because I had some, this offset was a bit off. I had to offset 1/2 of a pixel for some reason, otherwise it looked weird. But now it's like a pixel perfect scale function. Okay, so then let's take a look at the world drawing, the map drawing tool. It looks like this. Let me map tool. So we can generate a map like this. You can see we have grass 0, grass 1, and all of that. And all these names are the ones we loaded in when we loaded the background graphics. We have a foreground tile, empty is the first one, and then all the foreground, the possible ones. You can see that I have a star on some of them. That's just my way of remembering that these are solid. I did the same thing here with the shore. Shore 0 is sand, and then 1 to 4 is actually solid. But I added another one. I can, in the background here. Here we can see the shore, where I have that graphics. And then I have these 2 lines where I add shore 4. That's a dark blue water. I add it twice. First as 83 and then as 84, and the difference between them is that it's solid or not solid, but they have the same name, just with that additional star. And the reason for that is I want the background, I want to be able to walk over the background. And so the background on this bridge is actually the dark water, but non-solid, so I can walk out on it. I tested a few different ways of doing this, and I think this was the most convenient one, because I can then have the bridge be on top of everything, and I can just add more background of different types if I want them to be non-solid. Okay, so now back to the map drawing. We can load a map, we can save a map, obviously. If I, for example, load the first map, like so, we can see that we have 40 and 30. That's the values from the file, you remember. So let's see, we have this entire map and more things we can do here. We can actually zoom to make it easier to draw. That's the maximum. And we can zoom out just to get if it's even larger. These can be at maximum 256 by 256. And if I try to generate a larger map, we can't do it. So it has to be according to the values I've given you before. Okay, so how do we draw? Well, let's say we generate a new map. I do that again. We first select a background. Perhaps I want some dead grass, and I want it to be 30 squared, like this, or this, generate. And then we start drawing. Perhaps I want some other grass, like this, like so. Different colors or shades of dark. We might want to have some sand up here, perhaps even some water, like that, and so on. And then we have the foreground where we can have trees. I draw them with my right mouse button, like this, and you can see I draw them on top of this the background. Oh, some winter trees over here. So basically doing it the logical way when you have two layers, and it's annoying to draw cliffs. I can just show you when you do like this, you need to keep track of what tile we're using and what place it should be in. I have no system for automatically just drawing a cliff. That would be something interesting to write. But anyway, this is how we do it. We can save it. I can also save it as an image just to keep track of maps or doing documentation or keep track of teleportation or whatever. So that's pretty much it. Now, how do we do this? Let's go through the important parts. We're coming to the main game part later, but I want to go through this first. So width and height, we have a byte array for the map back and byte array for the map front. And the byte array is then from these values. So the background is using all these 83 and then every second. And then in the front, I'm storing all the values for the foreground. And then I have some ways to keep track of mouse, so I can draw. Why did I close it? So I can draw, I keep track of if I have the mouse button pressed or not. And I don't want to update as soon as I move it, only when I move into a new tile. So I have some checks for that and some minor things to just make it more efficient. We have the scale factor that we change with the plus and minus, and some fixed values for max and minimum, of course. Here are the graphics that I load, and that's the first thing I do. So I just call the DLL and load the backs and the graph and the front. I fill the boxes with the names, and then we're pretty much ready to get started. Going through the list, just checking the name of the tile, returning that, adding, and also I have an event for when I'm selecting. I'm going to change this. So there's an event every time I do this, and that event, it's the next one. That means that I want to change the background image over here, the preview, so to say. But you can see that I'm drawing this. It's much larger than this one. So here I'm using the resize bitmap that I had in the support file. just based on what I've changed or the selected index, and I'm just sending that image from the tile, and then the scale factor. So I'm drawing this with 3 times the tile size. Same thing for foreground and for background, and then we generate. So what we do here is that we create a new map in case we have the correct size and all of that. Create a new byte array for front and back, and then just fill them with what we selected. So if I selected this one, then that should be in the background and then empty in the foreground. So empty in the foreground and then the selected in the background. And we redraw it, and we just set things to load it, and we make sure we are have everything in correct state so we don't crash. And then we can start drawing. So it's actually not too bad. Going through the width and height, we are keep track of the scale factor to make this picture box. And well, yeah, I'm doing this in a Windows form. It's not the way to do it, but it's an easy way to get started. And I just wanted to test things in the beginning, and it grew by mistake. But anyway, the way to do it would be probably quite similar in regardless of what you do this in. So I'm keeping track of the size of of my field, so to say. And then we get started, and then we have this fun thing with lists where you can actually search in a list, and it looks really advanced, but it's not too bad. So I'm looking in the byte array for what value we have there, and then I fetch the graphics for that byte value. And that byte value, we look in the list of tiles, and then we just draw the image in it. This image is the one that we had up here. This one in the class. You just draw the tile size, and we'll draw that in a bitmap that we generated. This is the size of the bitmap, and in the end I just place that bitmap in the picture box, but I'm doing it through the resize bitmap method, and that will then I just need to make sure we have the scale factor set, and I only rescale once. In the beginning I had the rescale on every tile, then of course I figured out that I can draw everything once in the original size, and then just use a scale factor and rescale one single time, and that's just before we draw it. And then we have a few functions for drawing, and then I mean drawing like this. I'm keeping track of and when I'm moving mouse, and if the button is pressed or not, and if it's a right or a left. And when I do that, I update a tile for every time we need to. For example, when I click, I update, and then if I move into a new tile, I update it. But I don't update if we're in the same tile over and over, because that means we would update for every pixel we move, and that actually made a big difference and a lot slower. So keeping track of where we are in the box and the tile size and the scale, so we can identify what X and Y we're in. And then of course, if we release button, then we stop draw. And keeping track of all these minor things to make it work in an intuitive way. So the update tile looks like a mess, but it's actually not too bad, like everything else in this code. But we need to make sure that we're handling transparency specifically in a correct way. Because you can't draw transparent tiles on top of something else. For example, if we have a bunch of trees, those are in the foreground, and I want to remove them, then then we want to draw transparency, but it basically means that we need to delete the old tile and redraw it. So first we check what button to press. Remember that we are drawing foreground with right. And we don't want to draw the entire screen, only the one we're looking at. So first we check the mouse button and we're changing the byte array value. Remember that this is only the value so far, not the image itself. Front is right button or middle or whatever. And then we load the graphics below. And if we have a transparent tile, we want to set it to transparent in that bitmap location. And then we draw the new tile from background first and then foreground. And then in the end, we just update the image with the same function as before. Because we loaded the bitmap first and just updated one tile, and then we set it in the new we set the new image in the picture box. We're just using lists as we've done before. You've seen it in a few places. Background tile, foreground tile. And then in the end, we want to export, and here we export to a file in this format. So the first is the Y, then the X, and then all the data. And of course, we do the same thing when we read a map later. So I'm going through it now, but it's the same idea backwards later on. So we want to store them as map files, and going through all of these checks. We set the correct size of what we'll write, and then we write the first Y value and then X value. And then we just loop through it. So every map, for example, the, where are we? Here, the 1-1, it's 40 by 30, or 30 by 40, according to this. And that gives us roughly 1200, I should say. And plus that we have another 1200, so times 2 for the foreground, and then plus 2 for these two. And that's of course what we see in this one. And then we just loop through the byte arrays and write the data. When we import, we're doing exactly the same thing, but the other way around. We read the Y, we read the X, and we create new byte arrays according to these values. I don't have any error checks at this time. You should have that, but I skipped it. And then we just loop through and we read all the bytes from the file, put them in correct position, and we redraw the entire map once we loaded a map. Export is easy. We can export an image. There's a built-in function for that because we're using, we have a bitmap that we save everything in. You can see that as a kind of a frame buffer almost. So I'm just exporting that to a file. Really simple. And then just handle the zooms back, in and out. That's very straightforward. And we're about done with this one. I have a small thing down here just to make it possible to scroll sideways. Going side like this, holding shift, we go sideways. That's not the built-in function for some reason. Okay, then I think we will jump over to the final. Or perhaps not the final, but the most important one. And this is the main program where we run the game, this one. So we have some support classes. We have a location. These will handle our teleports. So a location is just any location. It's just an X or Y coordinate. But we use this location in the teleport class. So we can set where we start, where in that map to start, and where to go, and where in that map to go. So that's just a teleport that will read later, and you know, from the XML file. And then we have a map. It has a name. We can see that in the XML file as well. That's a name. Also a file name. That's good to have, but that's not in the class itself. And then the map must, of course, have the background data. That's a byte array for the background and a byte array for the foreground. So let's start from the top, and I will not go through everything. We have quite a few. We have 600 lines in here, so but you can pause at any time you want. We have lots of these keep track of our size and in pixels and the tiles and all of that. And apparently we're using scale 3 for this map. Where we're going, where we're heading, the direction, we need to have the correct graphics for our night here. So we need to keep track on the direction. And I also have this row to keep track, or just to save the value for diagonal movement. So if I move 1 pixel per step, so to say, per operation in these directions, I don't want to move 1 and 1 when we go diagonally. So that's why we need to have a calculated value for the distance to step when we go like that. You can see when I face a wall, I walk slower diagonally than I do straight. So that's intended as well. And then let's get started. We have the back graphics in a list, we have the front in a list, we have byte arrays for the maps, and we have a list of maps that will read from the XML file. We have a list of teleports that will also read from that one. And let's see. Yeah. Moving and the player and all that. We have a sprite selector to keep track of what pixel or what tile to draw. They're basically tiles as well. They're 16 by 16, a bunch of them. There are 5. 1 for standing still and 4 for moving. So load, we load the player. Let's go quickly there. That's just looping through the sheet. I could probably have this in the support class as well, but it ended up here and I didn't bother to move it. But it works in the same way. And then, of course, the maps, we need to load them. That's quite important. Here's an XML, and I will not go through the XML read because I didn't like the XML, I didn't want it, but it's the first thing I got working for this system. I would probably prefer to have some other format. It's not very compact doing it like this, but it was a first take, okay? But we read the name, we read file names, and we need to add maps based on the file name as well. Yeah, so here we add the map. From the first ones we read, we add the map. And add map is different. It's where we read the file itself. So if we can see that we have a name called map11 and a map file 11.map. And those values are used here to read them, so we can save them in our list of maps. So we add the map to the list of maps. And then we have read all these byte arrays and stored them in memory. Then looping through, we need also to add teleports. The good thing with lists is that you don't need to define them beforehand what size or length they should have. So we can just keep on adding things to the list of teleports. and of course to the map as well. So we do this, the origin, destination, and destination, what map and what location in the map we're going to. And we're just reading all those values from here. Okay, so let's leave the XML. It's pretty straightforward how to read it. It's just a lot of code to do that. And then after that, we need to load the first map where we are. And I have hard-coded that we'll start in map 11 at location 2011. This should probably be in the XML file as well. But we're just loading and searching in our list of maps, and I'm searching for this name. And then we return the map and we load the map. And that means that we need to make sure that the current map back and front is what we have in the map. And when we change map, we'll replace these. And then keep track of the position that we're in, place the character in this position. And then keep track of where we came from, so we can teleport it. So we don't, I mean, if I walk into a teleport like this, I end up in this tile, but I don't want to teleport on the first pixel like that. So only when I get back into the tile. It's not the most beautiful solution, but it's how it ended up. And I started with a more precise map load, but I never finished it because it didn't really make a difference for this application. And then here I also set values, and that means if we have a map that we want to scroll in, or if it's a map with maximum size in X or Y. This comes in place later when we draw the map. And we calculate where we are horizontally and vertically. That's something that updates every time we move. We need to make sure that we are where we're supposed to be. Okay, we'll come back to those a bit later. But first I want to continue. Yep. We set the size and then we update the screen, and that's when we draw. And this is quite similar to what we did before, that we draw the background and the foreground. So we have graphics back and graphics front, and we loop through Y and X. And here we have the screen reduction. That means if we should load one extra tile for scrolling maps, or if we should just load enough to a static map. That's why we have these in here. And we're only scrolling from the visible part. So in a fixed map, we'll start from 0 and go to maximum. But if we move around, then we'll start at perhaps tile 10 in Y and then loop down to 15. Or no, we'll loop 15 times down to 25 or 26 to be able to scroll. Okay. And then we just draw the image. It's actually quite simple. That's the player, background, foreground. Keep track of where we are if we're scrolling. Draw the player on top of that, and that's our position. And then put it into the picture. And then that's basically it for drawing. And then now we have everything in place. Now we can move around. So we can check our position. That means if we are at the edge, if we move into a tile, then we should check if anything should happen. And that in this application, it only means shall we teleport or not. So making sure that we are in the tile. So I'm not standing now. I can't be on the side, but if there's a town, for example, then I will not go into it if I'm placed in the middle. I need to be within the entire tile. So I keep track of that. So I'm within the tile both X and Y. And if we're in there, then we can set that, oh, now we have moved into a new tile, and then we can list the teleports for that location. And here's just a different way of writing this part that you've seen before. This is how I usually write when I look into a list, but this is doing the exact same thing. It looks like a database more, and it's easier to follow actually. So I check teleports in the map, and then kind of mask out if I'm in the correct position, and if I'm in a teleport, then we should load a new map, and what map, and then where to send the character. So I do this every time I walk into a new tile. And then we have some fun part where we move player. We need to make sure if we're moving diagonally. I'm doing it like this. Here first I check if we are, what keys we're pressing. So if we check any key is pressed, then I set them to true if we're moving up, or W, then we're moving up. And if we're moving, clicking S or down, we're moving down. And we can have both, we can have several true if we're moving diagonally. So I'm just setting these to true or false at all times. And then I can set the player direction, and that means what graphics to load. And let's see. And then we can move the player. So if we have diagonally up left, then we'll move position Y according to the length that we defined before for diagonal steps. And we'll check the vertical position, and then I move the X one and check horizontal position. And then I do this basically depending on what combination of keys I pressed. I always move them, check them one by one. So if I move into a solid object, I will still move sideways, but not upwards. So I will never be stuck when walking diagonally. So that's why I have all these different ones. And then we'll need to check vertical and horizontal position to set our X and Y, new X and Y value. And these are probably not the fastest ones. I had them working first, and I simplified them into only a few options. So I would really like to do this in a better way, because there are quite a few checks, and I don't think this is very efficient, but it works perfectly. It's fast enough for this application. The important part here is that I want to determine what position my character should be on the screen. So when I move up like this, and we reach the point where we stop scrolling, now I still want to move my position, but I also want to move my position on the screen. When we are in a map where we're scrolling like this, then we're always in the middle. Exactly in the middle, all the time. But facing any side, I want to stop scrolling and then just move the character. And that's what we're doing here. So I need to put my offset, I need to make sure we're so we won't skip a pixel, or we're jumping 2 pixels when we walk from a still map to a moving map. I had lots of issues with that in the beginning. So sometimes I moved 2 pixels and in one direction, and when I fixed that, then it was on the other side of the map. I moved 2 pixels when I stopped scrolling. So yeah, this was annoying and hard, and well, not too advanced. It was hard to get everything in order. I'm doing the same thing for vertical and horizontal. And I think with that we actually covered all the important functions here. I have, of course, a way to check if a tile is solid or not, but that's pretty straightforward. We don't want to move into something that is solid. I have a timer for to keep a steady frame rate, or somewhat steady. And so I can draw the character, and you know, if you press a key, there's first, you press once, there's a pause, and then you move a lot of, well, much faster. And I was using that for quite some time, but after it felt so budget. So I moved into a timer tick, and it made things not harder, almost easier, because then I could keep track of my movement and change step counters, and it was quite a logical way to do it. Yeah, so then let's just quickly jump into the final piece, and that's the where is it? The location tool. And the location tool is where we, let's see, I'll open it up, where we define our map. So if I load a file, our map data here, this is basically the XML file, but in a tree view. So we can see that we have the map name here, that's a 1.1, and the file name for that, and then the teleport origin, map destination. So here we're actually doing the exact same thing as I showed you before, but I'm handing all these functions to, I can delete a teleport, I can delete a map entirely, we can add a map at the bottom, and then we need to give it a name like that, and we'll have a file name. It should be asdf.map. And for this map, we want to add a teleport, and that is in 10.10. There's a teleport, and it goes into destination for the map name, not the file name, but the map name. And so it's perhaps map 1.2. That's this one, I think. Yeah, map 1.2. And then we have a destination. So we can add all of these and delete them. So very, very simple, simple program. And I'm basically doing XML handling for all of these nodes. Let's just run through it very quickly. I don't think there's anything interesting really. So open file, we're reading an XML document, we're keeping track of child nodes, and to keep track of where we are in the trees, how many childs there are. I don't want to be able to edit this, but I want to be able to edit this one. So some of those checks, I don't like XML because I don't understand it fully. I understand how it works, but I know there's a simpler way to write. You can have name, could be like map 1.1 here, and then you can just skip. You can do it like this, I think. Or is it even simpler like this? So there are ways to make XML more compact, but I didn't get it working, and I didn't bother. But we need to add nodes, and we're running this open, and we add node, and then if we have another child node, we need to add it. So we're just calling ourselves. That's how we can build a tree. Save is something similar. We save nodes, and then over here we save, and then we save nodes again, so we can save the tree view as well. So a bit tricky to get working, but now it's stable, so I didn't touch it, but I would like to change it into something else. And And then there are lots of checks to see, so we can delete maps or delete teleports. So I can actually stand, even if I'm here and I click delete map, it will find its way down to this map. I don't need to stand here and delete. I can be here and delete map as well. Same thing with teleports. If I just have this marked, I can delete the teleport, and that will delete the entire teleport tree for that teleport. You know, we can have several of them. But if I want to delete only this one, I can stand wherever I want. So that's what I do here. It took me a few minutes to get working, but it's not... It looks stupid with parent.parent.parent, but it's not. It's actually quite logical. And well, I think we'll stop there. It's not more interesting than this, and because you can't do much more. Of course, we could add some animations for slashing with the sword. We can perhaps add some other mobs. We can add more caves. Now, I didn't find the file I was looking for, but it's important to keep track of all the teleports. So here you can see that I'm actually placing the character in front of the cave, so we can move around. But if I do anything wrong here, for example, when I go up here, I left this on purpose after doing it by mistake. This is not how to do it. So it's important to keep track of all. Now I can't go, I think I actually can go back. Yeah. So lots of things to keep track of. And all of this started as just a test if I could do something that scrolled around and keep the player in a logical place. So my inspiration was kind of like Zelda 2 Overworld. And I actually used... I wonder if I have them. Here you can see. So here is how I added the teleports. Now I found the file that I was looking for before. So keeping track of coordinates like this when I did the map making, the map tool, the location tool thing. But the game looked very much like Zelda 2 Overworld before. Not too advanced graphics. In the beginning, it wasn't even doing that. But it's... so you can see where the inspiration came from. And the new graphics looks really good, and there's a link in the video description to where I borrowed it from. It was open and public, so it's okay to use it. So I think it was a big step up. Kind of prefer this. Hope you do too. Anyway, that's all I had. If you have any questions, feel free to drop them or discuss it on Discord. It's not what I usually do, but I think it was a fun side project. And since I put some time into it, I wanted to show it in more detail. So anyway, I hope I'll see you in the next video. And so take care and bye-bye.